All right, thank you for coming during these COVID times. I'm very happy to see you here. I will talk about the dinosaur wars, which simply means we had lots of fights, 4 decades of it. Actually, we're going past, we're going to the 5th. And the question is always, was it really an extinction because of an impact, an asteroid, meteorite impact, or could it have been volcanism? And at the beginning, of course, volcanism was completely eliminated because the very man who created the theory didn't want any competition. So let's start right here. Hey. Why is it not moving? It doesn't start.
No, it will happen.
Okay. So basically, I give you a short introduction to that. I'm sure we are familiar somewhat, but actually, I could talk for the next 4 hours. But I won't. So 66 million years ago, a meteorite crashed into Yucatan and in an instant caused a mass extinction. That's the idea. Of the dinosaurs and also 75% of all other life forms and global wildfires, followed by darkness and a nuclear type winter. That was the idea. This is the impact theory that ruled as the sole cause for the 5th mass extinction, which is the dinosaur extinction, in Earth's history for the past 40 plus years, tolerating absolutely no evidence contrary and eliminating all deposition within the first few years. From the very beginning, the media loved this sexy story, and so did the public. And many scientists jumped on the bandwagon for a very easy ride to fame. It was and still is the most nasty controversy. It tolerated no alternative hypothesis, silenced and eliminated any opposition by bullying, name-calling, ostracism, attacks on science integrity, prevented publication of evidence contrary to the theory, destroyed careers of scientists questioning the theory, and created a silent majority of scientists that still doubted the theory. They were simply sitting on the fence. I will tell the highlights of the dinosaur wars as one who was in this nasty controversy from the very beginning. And despite all opposition, searched for the truth. That's all I wanted to know. What really caused this? And so I only have 155 minutes or so to cover 40 plus years. So I'm going to just choose some choice examples. First of all, it all began with the hypothesis. And that is, of course, the large asteroid that hit the Earth caused the dinosaur mass extinction, along with the 75% of other life forms, resulting in a nuclear winter, cooling, global wildfires, etc. It was published in Science in 1980 and the first author was Luis Alvarez, who was a physicist, Nobel Prize winner, and his son, Walter, was the geologist. Naturally, Luis Alvarez didn't know a damn thing about Earth sciences, but he knew how to fight and how to eliminate people. In particular, here, it was mostly the iridium anomaly where he based his hypothesis on. Iridium is common in space rock, space junk, but it's also equally common inside the Earth. and both about around the 600 parts per billion. And so it comes out to the surface through Lip's volcanism. And of course, Louis Alvarez did not have any of that. I won't tell you, but the one person that had already proposed Deccan volcanism in 78 as a potential cause was eliminated within the first year. He basically, it's a long story, but he literally made this guy so sick that he was out of it. So there is an interesting study. There are two books that named, one is The Structural Scientific Revolutions by Thomas Kuhn. Maybe some of you know that. There is another one, a more recent one that does the same thing for physics, and that's Smolin in 2006. They're actually fantastic books. I started reading those when I was already 3 decades into the dinosaur wars and find, oh my God, now I understand it all, because this is actually exactly what has been going on in these major controversies 2 centuries. So first you get into the hypothesis, then it's the theory, then it's the crisis for the theory, and then it's the emergence eventually of an alternative theory. And in our case, that's now volcanism. Also, I should say re-emergence. And so the phase 1 hypothesis that they described in these books is that it's the discovery of an unknown anomaly, in our case, it's iridium, requires extraordinary explanation. Data that contradict the hypothesis requires notification or dismissal and denial. And in the dinosaur wars, this is exactly what it evolved into. And I would call it a story told of facts and lies. First, the scientists lose perspective in science instead of belief in the rightness of a hypothesis or theory. Second, they progress from fact-based to belief-based interpretation, which is truthiness. And third, they use the controversy escalates into heated arguments, accusations, and acrimonious personal attacks. And the fourth is the new discovery supports an alternative hypothesis and requires modification. So we virtually have every one of these. So I interject to go back one more thing. How do you think that the impact theory could be so successful and so quickly? And within 2 years, before anybody even could provide any outside information other than what the impactors had. And it is simple. Mostly it's from Louis Alvarez, the Nobel Prize winner. Everybody knows that an impact caused a mass extinction. That was where he began with everything. Only old-fashioned Darwinian paleontologists can't accept that the mass extinction was instantaneous. In other words, people like me and every paleontologist and lots of geologists. Criticism can be dismissed on grounds of general incompetence. There was never any science talk from him. It was always this accusation. And then the last one, it must be true, because how could so many be so wrong for so long? That's an anonymous reviewer of one of my rejected papers. Well, I did not enter the field. I was working actually on this mass extinction when, in 1980, when Louis Alvarez came on the horizon. And within a couple of days, I found that there was no way I could continue because I would have to jump on the bandwagon. I would have to agree with everything. And I would have to eliminate any idea of having actually looked for truth. And so I decided I would give up for 5 years and work on something else. And in 5 years, all this would be blown over. And I was never in my life more wrong because it's still going on. So in 1985, I started. In 88, there was this NASA-funded Impact conference in Snowbird, Utah. It's the second one, and NASA funded, I should say, virtually every one of these impactors, because NASA, you have to realize, was in danger of losing a lot of funding. It was under President Reagan at the time. And Luis Alvarez's impact theory was fantastic because they could make a lot of headlines and everybody paid attention and they would get funding. And within just 1 year, they applied for $150 million to just search for a space rock, the nemesis theory. So when I gave this talk, and at the Snowbird meeting in 88, and I used this slide because I looked at KEF, the main stratotype section, and there was no instantaneous mass extinction with everything but one extinct. So rather you'd have nothing seems to work out. Something okay. So you see some extinctions before, some after, and then once it's survival, and then the evolution. Basically, all of the ornamented, highly specialized species went extinct, and they were endangered already at the time of the extinction. So I told them that it couldn't fit the impact theory, but it must have been high stress conditions a long time before. And then pandemonium broke out in a call of 500 people, 3 microphones set up in hallways up the steps. And for 45 minutes, they screamed at me and yelled and all kinds of things. It was fantastic. So let's go back. Phase 2 of the scientific structure is essentially the theory. By 1990, they could really succeed with the theory. It was a new discovery, officially according to the structural scientific revolution. The yellow parts is what I put in what replaced it for the dinosaur wars. So the theory is a new discovery confirms the missing link of the theory that was present. And in our case now, was it the impact cradle? And related discoveries, the impact spherules, give it the status of a proven theory. Data that doesn't fit the theory is routinely dismissed or ignored, and dissenters are bullied and marginalized. And that's, again, what happened, of course. So in this case, the impact crater was Yucatan, Chicxulub Impact. And it was essentially, it wasn't really a new discovery because it was already known in 1980, but nobody paid attention at that time. But when they first found the impact spherules in Haiti, they knew there had to be somewhere a crater, and that's what led them to it. So within what was really remarkable here, while they proposed this theory, within less than a year, 9 papers were published by Science and Nature, all confirming the truth of this. There was not a word of questioning. And at the same time, there was absolutely no age for the impact failure. They didn't know what it was. So the next step was a frenzied search for the impact spherules to actually prove the age. And it was Jan Smith and Alvarez that published a paper in 1992 in Geology. And they claimed that they found they have to prove that it is exactly at the peak boundary. And except there was no evidence of it. So I think I was. So by then, when this came out, I basically gave up. And I decided that maybe for a lone woman fighting these guys, it was time to cut out and do something else. And then there was a guy named Chuck Officer who already had been eliminated by the impact guys. And he kept calling me and pestering me and said, you need to lead a field trip to northeastern Mexico to see whether this impact tsunami that is supposed to show that the bottom of the spherule layers and umpteen meters higher up where the iridium and the mass extinction is are caused by a tsunami. And it wasn't a tsunami. So that comes later. Shouldn't have given you that tip. But in any case, so eventually I thought, all right, and I put together a group. And in 93, actually in 92, later in that year, we went to northeastern Mexico. And that's actually where I met Thierry and Wolfgang Stinesbeck from Germany, who was then teaching in Mexico. So we were looking at these, and by the way, and it was the first time that I actually had collaborators. And then it was really nice. So what we were looking at these rocks is what makes these a tsunami. And we found absolutely no evidence, but lots of evidence that eliminated tsunami. For instance, we found that there's a lot of burrowing sea life throughout these deposits that was supposed to be the tsunami. And by the way, the reason they wanted a tsunami is the following. And that's why this picture is there. Okay. The reason was that down here is this first spherular layer. That's the normal sediments. Then there is this sandy limestone, and then again a spherular layer. How can a tsunami create a limestone, which is precipitation and takes thousands of years, about 15 to 20 centimeters thick. After that, we have a sort of a sandstone that is relatively undisturbed, and that can be just a gravity slump. And then on top, which you don't see in details, here there are 6 meters of laminated sediments, mostly shales, marls, and some fine sands. And it's totally burrowed and trace fossils. It's a seafloor that is absolutely colonized. Now, you cannot have a colonized seafloor during a tsunami. And a tsunami would be within hours to days, if possible. Also, what Thierry found, there were about 4 layers of volcanic origin. So again, you cannot deposit that either. So we had the multiple spherular layers below the mass extinction. We had the burrows, of course, and the limestone. And there was absolutely no evidence of a tsunami. So this is our next team, or my next team, my first team. And it's mostly with Thierry and Wolfgang and some more German geochemists and my students and some other students. Over the next few years, we basically analyzed dozens of these channelized deposits where the spherules were always laid down. So each one of these deposits are channelized in about 150 to 300 meters wide channels. The depth of deposition was about 500 meters, and the spherule layers were always at the bottom. So you had the usual, and besides outside this channel deposit, you would never find any spherules or anything. It's only inside the channel. So that's another problem for the tsunami, of course. It doesn't just restrict itself to that. So we had now dozens of these localities, and they were all very similar. Reworked spherules in the upper part with a lot of shallow water material, including wood and plants, debris, and so on. So in 2000, I usually took my students every year down to Mexico and taught them about this impact theory and how wrong it was. And one summer in 2000, I had some eager guys who said, well, if you're right, that the impact predates the mass extinction, then where should we want to go and check it out ourselves. Where can we go and dig? So we bought them some shovels and picks and took them out in 115-degree heat. And I told them to dig a trench down on the side. I wanted to do that for a long time, but there was no way I could dig that. And they went ahead, and it was the lucky day. 4 meters down, we found the pristine impact spherule layer. That's 2 meters thick. This part here, that's the trench they dug, and below here is 2 meters of sediments. And it comes in essentially 4 layers. But the interesting thing is, I'll show you that in the next one. At the very bottom, there is this velvet glass. It's like the hot spherule first rained down from the sky and welded together into some sort of raft that then sank very rapidly. There is no sediments in any of these spherules. There's no contamination. There is no shallow water debris like in the reworked ones higher up. So it is the primary deposit. When we submitted this paper, of course, we got rejected because this is a problematic one. And we had 2 reviewers. They were anonymous, but later on they were not so anonymous. It was Schulte and Smith. And this is the cartoon they added, and which cinched it for the editors, which were mostly impactors. And basically they said these are the reworked spherule layers. There's the limestone in between, and this large one down here is the 2 meters thick one. So what they said is it's a ball and pillow structure. And the tsunami just was shaking it, and it all came down 4 meters through, and then they would spread out on the sides, but they didn't know just how. So I always like that cartoon because it's so stupid, it's unbelievable. So we submitted that paper to 2 other journals, and we got exactly the identical reviews from the same 2 guys and exactly the same rejection 3 times. And I did blow up. The truth is, I did blow up on the last one, which was the Journal of Geological Society of London. And the editor said, went to read it himself. And then he sent me an email and said, I'm sorry, but you're right, we'll publish it. And so it did eventually get published, but it was 2009. So it's not that easy. So I'm going to take a quick turn and talk about the Chicxulub crater and the age of that. So the first thing I want to tell you ahead of time is about the vanishing cores. Have you ever heard of the vanishing Chicxulub crater cores? Maybe none of you. It's an amazing story, and each one would have a story on its own. But basically, the impactors were in a hurry and in need of proving that the age of the crater is KTH. And so the first thing they did is get the Pemex cores. That's the 1990-91, where when they had discovered this crater, Pemex had already drilled about half a dozen holes through this structure. And they got samples for it. And I was given 1 sample to analyze the age by Hildebrand, Canadian guy who was the first author on this. And it was 90 meters above the impact structure and 6 meters younger, 6 million years younger. So I told him that I needed more samples. And he tells me they're all burned in a warehouse fire. There was never a warehouse fire. But they believed it until about a year later, when they had a meeting in Mexico to propose the drilling of Yaxcotil 1, the second one, no, third one. And I met a guy there who seemed about as awkward there as I. I was invited to that because they needed someone that was opposing it to satisfy National Science Foundation. And he asked me what I was thinking about it, and I said, it's stupid. I don't believe that there is a warehouse fire that burned all these cores. They're just hiding them. And he said, who says that? I have the cores. He had half of them because his predecessors had worked on those cores as a consultant many years earlier. So he and I actually, and Thierry and Wolfgang, we worked on these. So we knew that, in fact, if I had gotten the samples that they claimed to have burned in a warehouse fire, I would have confirmed that it was actually Maastrichtian above the impact crater. And that's why they had made them disappear. So the next one was the UNAM cores. In 1995, the Mexicans, with some help with the US National Science Foundation, drilled a hole. And they had also right across the boundary, that is down into the impact structure and impact pressure. And we got some samples. Wolfgang got samples, and I did, and Thierry did. The problem was the following. They took away the 50 centimeter core that was critical. It just vanished. Period. So this was the second one where it vanished. And then there was the third one. And that was the big one, the Chicxulub one. And it was US continental drilling. And there was again 50 centimeters between the breccia and the Kitty boundary. And they had a meeting at UNAM in Mexico City for people to look at what samples they were going to get. And this core vanished during the meeting. And there was a frantic search, doors locked, everyone was searched, everyone helped search, and guess what? They found it eventually in the duffel bag of Jan Smith. And that was it. But then Jan Smith, simply claimed that he took it because he was allowed to take it. And then a few months later, he did get permission from the other PIs on the impact side to take the core because he promised he would hand out these samples in time for us. Anyway, I'm the only one that got samples at that time, and that's only because I threatened. The last one was 2016. I will talk about this one later. The last one was 2016, the latest one where they drilled again. And guess what? The cores are absolutely vanished into a hole at the University of Texas, UT Texas, where Sean Gulick, who was one of the two PIs, is controlling it and will not give samples anybody but his little clique. And every year you get another stupid article published by Science on Nature with some fantasy of the second by second way that the mass extinction happened. Of course. Someday soon you will find out that all that is nonsense. But I can't let it out right now. So this is Chicxulub 1. And what you're seeing here is indeed the 50 centimeters here all the way, and then the mass extinction boundary here. So all this limestone here with some, slight wave action, draping, this is Yucatan platform, so it's very shallow. And then there are all these green layers, which is vulcanite, and also a lot of pearl here. And again, vulcanite and volcanitic clay, which Thierry analyzed as having deposited over thousands of years. And so we actually, Smith and Impact first gave the first talk, I gave the second. And Smith claimed that everything was proven, the impact theory was right. And I had the same samples, and I told them everything is not proven, it's just the opposite. And that created pandemonium. So by the end, these were the impactors actually practically had no real data. And we had at least 7 lines of evidence, including, of course, the age, biostratigraphy, the from 29R data, which incidentally magnetostratigraphy, which incidentally was by one of the impactors who collaborated. And then we had that was 13. How does that happen? 2 times. This you call this high tech?
Here.
I don't want that.
It's okay. It just
All right, now I have to find where we are. Yeah. Okay. I see. I'm not high tech. I'm an old lady anyway, so who cares? So then we are, and then of course the forams, which were also CF1 zone, because that's about the last 200,000–300,000 years before the mass extinction, and a little bit of worms. So this was absolutely horrendous for the impactors because it just went viral. And then a year later, Nature rejected my paper that I submitted to Nature first. And they rejected it actually almost without reviews. And then PNAS, which published it within a couple of months. And they got downloaded more than 1 million times in less than a year. So it really had gone viral. And the problem for the impactors was they couldn't do anything about it. And so what they did literally was deny that it was any worse. It was all mixed up. They had to drill again. And that's what the drilling was for 2016. It took that long, 13 years. So let's go back to the structure of scientific revolutions. We are now in phase 3, the crisis. This YAX-1 core was really the crisis. And so the significant new discovery undermines the central theme of the theory, and more discoveries follow. Doubts have been raised and the theory is in decline, but fiercely defended through denial, bullying, ostracism, misrepresentation, and personal attacks. So it's not my voice, this is actually in these books. So our significant new discoveries, of course, were the multiple impact spherules from Mexico, and the Chicxulub Impact crater itself that showed that it was really pre-KT as well. And the new cores drilled in 2016 are actually identical to this one. So by then we had analyzed about 300 localities across the world. And we, as far as Chicxulub was concerned, we had not found any convincing evidence that indeed there was an impact at KT. And so we figured that it was time for Deccan volcanism in India. I actually had wanted to go there for a long time, but it's a continental basalt. And I work with marine microfossils. So there's nothing really I could do. And Vincent Cortio, who I've known since early 1980s, he would always call me and say, Gerta, when are you coming to India? And show us where the KT is. And I would say, whenever you find marine sediments between some lava flows, I'll be there. And so it was, I think it was 2005 that he called and told me that they had it. And I couldn't go to India at that point, and Thierry went with Cortio's group. And that's where we found the first actually KT boundary. And I think I put in this one a little earlier, but this is now my Deccan volcanism, my first Deccan volcanism team. Or I should say ours, Thierry and mine for the most part. And this is one of the Rajamundry quarries, because that's where Vincent's group had found this particular. This is essentially a shallow water Danian deposit. And below it, there's the lower megaflows and the upper megaflows, lava megaflows. The upper ones are in the Danian, the lower ones are the uppermost Cretaceous. And within a few years, we actually had all these points here we had analyzed and succeeded one after another to actually find evidence that that KT was right in between the lava flows. So, but in this case here, for the Rajamundry quarries, it wasn't possible because we could not get underneath those lava flows to see what the Cretaceous was like. There was just sand because it was essentially a beach deposit. But then we went to northeastern, we had samples, we never went there, in Meghalaya because they wouldn't let us in there. But it is the best KT section, one of the best ones in the world. And then there was, I wanted to drill close from Rajamundry towards the Bay of Bengal, which was not possible because it's land that belongs to the government and nobody could get in there. And the reason was because the government oil company, Oil and Gas Corporation, was drilling there and they had drilled so many holes. So I decided, and I also found out that the KT would be 2,500 to 3,500 meters below the surface. I would never have, I could have money to drill 100, 200 meters, but not thousands of meters. So every Indian told me that it was impossible to get any samples from ONGC's library. And Thierry had a story that he tried to see them once and took him 2 days waiting and begging outside so that they would let him in to see the core library. And it was only to see, but not to touch. I like that. In any case, so what I did is I invited myself to their headquarters to give a talk. And surprise, within a week I was accepted. And so by the time I gave them my talk and was interviewed from the top down, they were in agreement to collaborate. And that was an enormous boom. So what we got in those is essentially, this is a composite of 9 belts. And what you're seeing is the massive stage, the first mega flow here. This thin level flow there already eliminated about 80% of the species. And it just didn't mean that that was the first. The Deccan, you can see the species are already going decreasing rapidly before. In other words, there was a rev up of volcanic eruptions. And then some of them went all the way across India and out to the Bay of Bengal. And that's what this outlier is. They formed essentially near Pune. And then they followed the Krishna and Godavari rivers all the way out. So there are 2 flows. And the extinction, I don't even know whether there were these few other ones that you see here were actually surviving or not, or that these were just reworked. But the mass extinction was very, very rapid in these very largest lava flows. And years later, of course, when we had actual dates, we found out that that these lava flows, these eruptions were almost continuous, one after another. So the question then, after we had that paleontologic type of data, is where do we get the age in the Deccan traps? And these are the Deccan traps. For those of you who haven't been there yet, take a trip sometime after COVID. Hardly any people in those mountains, so you can go anytime. What we needed was UP zircon dating, because that's the highest precision. And I had some money left that I didn't use for drilling. And so I went to my colleague, Blair Sherney, who has uranium lead dating lab. And I went to his office and I said, Blair, I have an offer that you can't refuse. I'm going to invite you to India to do some age dating, and I'll pay 2 of your students and your analysis. And if I'm right, then your career is made. And if I'm wrong, then you had a great vacation and didn't cost you a penny. So he said, so what will it be? And where would I know that the zircons are not in the Deccan traps? And I told him, no, but I think they're probably in the red balls. He said, no, no way. There's no connection there. So anyway, he took the bait, and this is the trip we took. So the first 3, there's Blair and his 2 students. And then, well, we have Syed in the audience, and of course, Thierry. And while it was not the happiest field trip, everybody was kind of depressed most of the time, saying that they're wasting their time. But when we got back, Kyle analyzed the samples, and within 3 days, he had zircons. So then the euphoria went. So since then, we have done a lot of collecting red balls, and every one of these red lines here is one of the red ball layers. Not every red ball layer has zircons, but about 35–40% do. And that's what gave us all the ages. And these are the red balls on the other side there. And what are red balls? They're just clays, red clays, but they don't have, there's nothing really in it that is of fossils or plants or anything. And the reason the zircons are in there is because there was some silicic eruptions, silicic eruptions somewhere else in the Deccan province, and they would fall out. And during this time, when the red layers indicate there was a time with no eruptions in that area, and so the clays accumulated. And so it was fantastic, actually. So this is the last paper in 2019. And what you see there is the vertical lines are really showing that the massive accumulation. And when you have transverse line there, it's because it was very slow during that time. So, and the error bars, as you can see, are relatively small. Well, this paper was published in Science in 2019, but it was withheld for about 9 months until the competitors from Berkeley, Impact Group, could do an argon-argon dating, and then they would publish that one with ours, with this one. And then, of course, they also wrote a summary with their own writer and promoted the argon-argon paper. Now, the argon-argon paper was, and this is what Claire did to compare, because the argon-argon paper said that there were no such accelerated eruptions. It was all essentially linear. But if you look at the error bar of the argon-argon, then there is no way you could actually know what the rates are. And so what I indicated there in red is the our data for 66.1016 million years ago, and the lower one. So this is the ability to put their data, which should be on.
You should stay in front of the computer, otherwise we don't hear you.
So, in other words, it tried to save the impact theory again. So now we go to the fourth phase. Emergence of an alternative hypothesis accounts for the observed anomalies and discoveries. Scientists flock to study this alternative with new methods, leading to confirmation of the alternative hypothesis. Confronted by the new anomaly, scientists devise ad hoc modifications to their theory, and that was the argon-argon one, and it gains strength and leads to a paradigm shift. The new hypothesis gains strength and leads to a paradigm shift in understanding of mass extinction. Exactly, this is what happened. So, as far as the impactor were concerned, they had the boundary further down, and they said that the impact triggered this volcanism. Of course, there's no evidence of that either. And then, so now we are in that Deccan phase 4, and yes, there was a huge increase in interest with lots of people working on this, and not just on the Deccan, but also on all the other mass extinction. So once we had succeeded with all those age shading, there was still one more thing to do, at least one more at the time. And that was, how do we correlate the Deccan now to the mass extinction? I have 5 minutes. Okay, so that's how we went to Mercury. And Mercury, really? Okay, so Mercury is what actually Steve Grasby and his colleagues in Canada came up with, applied to the Thermotriassic. And it is not, of course, Lips volcanism brings up Mercury, and Mercury has a residence time in the atmosphere of about 6 months to a year and a half, and then it rains out. And then if you measure it in the sediments anywhere in the world, you'll have peaks coming in with these eruptions. So this is what we did. And on the middle there, this is our first Mercury analysis of the stratigraph section in Tunisia. And we see all these peaks. We call them EE, extreme eruption. And we dated them with cyclostratigraphy, and then we tied them into the UPV dates. And the correlation is remarkable. So next we needed another, to look at the correlation with the stable isotopes. And what we're seeing here is the Mercury next to the isotope record in the same section. And of course, the extinctions are changed in the environment. And so what you're seeing is from the beginning of strong volcanism, the climate warming, and then it goes down. There's a short cool event, which incidentally is where everything ends in the deep sea from erosion, but not in the shallow, in the shelf areas. And the shelf areas, it's hyperthermal warming, where those are the Rajamundry longest lava flows. So we published that in 2020. And then I started working back into Mexico because I wanted to see whether we could get a Mercury peak related to the primary Chicxulub impact. And so there are two things that are important. One is that the mass extinction really happened with hyperthermal warming. And that's essentially what we are expecting is going to happen by 2050 or shortly thereafter. And that's what might wipe us out. And then there is the EE6 extreme event that we also found the same in Mexico. So now we have 3 localities. We have Tunisia, Israel, and Mexico. And each time the peaks, the volcanic extreme events are the same. And the Chicxulub impact coincides with that EE6. So I'm going to skip this one. This is the one where the students were digging for this 2-meter thick one. So now the mercury data is here, and EE6, which that big eruption event is actually just a short interval below the impact spherules. So the impact, the Chicxulub impact basically dates around 200,000 years before the boundary. And I have about more than a dozen localities now. And it's really a piece of data that we can't really deny, although of course the impactors will deny it. So, and this is even better. So we took that sequence, we do the same section, we analyze each species, relative abundance, and that's easy because below the impact versus above the impact, there is basically no change. So we have a Chicxulub impact, the one that is supposed to have wiped out everything, that didn't wipe out a single species. And then we go to the top, and these are what the impactors want to have as the boundary level. But the boundary is up here. And you can see that it just continues past this sandstone channel deposit and goes up, and then we have the just below the boundary, the hydrothermal warming. So what more can you want? It's absolutely convincing, at least to me. So, conclusion, Deccan volcanism is the primary cause of the mass extinction. And the deadly effects, by the way, the extinction really happened, we estimate now over no more, maximum 8,000 years. And it's mostly the rapid pulse extreme eruptions, the hyperthermal warming before the boundary, the ocean acidification, the poisoned atmosphere with mercury and other toxic, and the starvation on land and oceans because of all of that. And I won't get to talk about what we expect for the next extinction, but flashy, right? But I can tell you that what we observe for the fifth mass extinction at the KT boundary is pretty much what we can expect if we continue with fossil fuel burning and end with hyperthermal warming. Ocean acidification is already well advanced, and our oceans are almost dead, very reduced. So I'm going to go one more here and leave it at that.